Hello, students. So, oops, excuse me. All right. So, FRQ number 6 is the one that most of us struggled on. But overall, I would like to say that I'm proud of the class. Most of you did very, 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 very well on the FRQs. So I was very happy to see that. But between number 5 and number 6, 6 was the one that the class was the weakest on, so I would like to go over that one. Now, I know my optics are not very good, so I hope maybe you can refer back to the document that was sent last week so you can see the problem, but I'll read it to you. So you have f of x, which is 1/3 plus 2 over 3 squared times x plus 3 over 3 cubed times x squared plus dot 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 n plus 1 divided by 3 to the n plus 1 times x to the n plus dot dot dot. So this is a power series. In part A, it says, find the interval of convergence for this power series. Show the work that leads to your answer. So whenever we do interval convergence, what we'd like to do is apply the ratio test. So let's first do that. But before I do that, let me rewrite f of x. So I have it here. This is 1/3 plus 2 over 3 squared times x plus 3 over 3 cubed times x squared plus dot 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 plus n plus 1 divided by 3 to the n plus 1 times x to the n plus dot dot dot. Now, I would also like to write f of x with the sum, just in case I need it later on. So n equal to 0, because this is n plus 1, and this is n, and since this is n here, then my x is to the 0 power. So that's why I'm making it n equal to 0. To infinity, that's my infinity, sorry. And then I'm going to use the general term, n plus 1 divided by 3 to the n plus 1, x to the n. Okay, this is what they call the general term, if you're not familiar with that expression. So now part A, find the interval of convergence. Interval of convergence, which when we do that, we want to do the ratio test. Ratio test. And the ratio test says that when we do the limit of the nth term divided by when you do the limit as n goes to infinity of the n plus 1 term divided by the nth term, if that limit is less than 1, then it converges. So let's do that. So we're going to do limit as n goes to infinity, and we do absolute value because when we do the ratio test, it's always going to be absolute convergence. Okay, of the n plus 1 term, so that's going to be n plus 2 divided by 3 to the n plus 2 times x to the n plus 1. That is the nth plus 1 term times the reciprocal of the nth term, which would be 3 to the n plus 1 divided by n plus 1 x to the n. And we want this to be less than 1 in order for this to converge. So limit as n goes to infinity. Let's simplify what we have inside the absolute value. So let's do the n. That's going to be n plus 2 divided by n plus 1. And let's see, the 3's, here's n plus 2 and here's n plus 1. So that's going to leave us with a 3 in the denominator. And, excuse me, this x to the n is supposed to be in the denominator. So that would leave us an x in the numerator, like so. And we want that to be less than 1. So if you remember, we can since this is n going to infinity, we can factor out all non-n factors. So I'll take out x over 3, limit as n goes to infinity of n plus 2 divided by n plus 1. Less than 1. Okay? And we know that this limit is going to go to 1. So x over 3 times 1 is x over 3, absolute value that is. So that means absolute value of x over 3 must be less than 1. So what does that mean for x? Therefore, x must be less than 3 and greater than negative 3. Yeah. So now what we want to do is double check the endpoints. We always need to test the endpoints. So here we go. We are going to test x equal to negative 3. So we are going to put negative 3 in for x right there. So what we will have is n equal to 0 to infinity of n plus 1 divided by 3 to the n plus 1 times negative 3 to the n, which I can rewrite that as a sum n equals to 0 to infinity of, now I can factor this down to be negative 1 times 3 and take that to the nth power, like so. And so then what would happen? Then this 3 to the n would reduce down with this, and so I'll have negative 1 times n plus 1 divided by 3 to the first power, like so. Alright? And so now we want to determine, is this series going to converge or diverge? So if we think about all our various tests, the one that jumps out to me right now would be our nth term test for divergence. Because if I take limit as n goes to infinity of my nth term, negative 1, n plus 1 over 3, well, first off, even if I ignore that negative 1, my n plus 1 is in the numerator. This is going to go off to infinity. Now that I have this negative 1, it's going to go to positive and negative values. And they are going to get increasingly large. Positive, negative, positive, negative, positive, negative, positive, negative. And so you can see that the limit does not exist, therefore diverges. You can review your nth term test for divergence for the rules. But if you remember, if you take it to infinity, if the limit does not exist, which that also includes going off to infinity, then the series diverges. Okay? And so we won't put equal to on the negative 3 because when it's equal to negative 3, it diverges. Now let's test x equal to 3. So if I put in x equal to 3, then I have n equal to 0 to infinity of n plus 1 divided by 3 to the n plus 1. And this time we're putting 3 in for x. So it's going to be 3 to the n. And so what happens? That's going to reduce down to n equal to 0 to infinity of n plus 1 divided by 3. And we can see that is going to go off to infinity as well. So limit as n goes to infinity, n plus 1 all over 3 equals infinity, or you can just say that it does not exist because infinity does not exist. But either way, therefore diverges by the nth term test for divergence. And so I wouldn't put equal to there either. So the interval of convergence would be negative 3 to 3. And that would be my answer. All right. So now part B. So let's go back to the problem. Part B, it says limit as x goes to 0 of f of x minus 1/3 divided by x. Now, I think this is a little interesting. Probably not used to this notation. Limit as x goes to 0 of f of x minus 1/3 divided by x. Alright. So we probably haven't done problems like this before. This is kind of interesting because we're taking the limit of a power series, an infinite series, and we're subtracting a value 1/3, and then we're taking that series and we're dividing by x. But if you remember, f of x, let's go right back here, f of x is equal to this big long sum. But the very beginning of that sum is a 1/3. So if I take this big long sum and I subtract this 1/3, I'm going to be left with what I have right here. So let me take baby steps. F of x, which I'll write it out again, 1/3 with plus dot 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 plus n plus 1 all over 3 to the n plus 1, excuse me, dot dot dot, minus 1/3 all over x. So what's going to happen? This one and this one say goodbye. And then what do we have left? We go, oh, look it. There's an x, there's an x. Well, there's obviously x's all the way up to that guy. So if there's x's and all of those, then what is this going to be equal to? Limit as x goes to 0. Let's see. When I divide this x into here, I have 2 over 3 squared plus. When I divide this x into here, I have 3 over 3 cubed x plus dot 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 plus. When I divide this x into here, I'll have n plus 1 divided by 3 to the n plus 1, x to the n minus 1 plus dot dot dot. And actually the formula would change, but it really doesn't matter because what's going to happen was x goes to 0. This is going to go to 0. All of these are going to go to 0. That's going to go to 0. Everything after is going to go to 0. So what is this equal to? 2 over 3 squared, which is the same thing as 2/9. Yeah. Okay. All right. So now let's see. Part C. Part C. It says write the first 3 non-zero terms and the general term for the infinite series that represents this integral. Okay, so part C. We need to integrate this. And then once we integrate it, well, since we're integrating a power series, we're going to generate another power series, and then we're going to want to find its formula. And what we need to do at the same time is we need to find the first 3. What they mean by a non-zero term is basically like this. See? These are the first 3 non-zero terms. And then the general term is this. So we want to find that for this integral right here. Okay? So for the first thing, what I would do is I would start off with integral from 0 to 1 of f of x dx, like so. And then, well, I would go, well, let me see. This is the same thing as 0 to 1. Okay, and I'll expand it. 1/3 plus 2 over 3 squared x plus 3 over 3 cubed x squared plus dot 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 plus x to the n plus dot dot dot, like so, dx. Okay, and so then what's the first thing we do when we want to evaluate our integral? We have to do the antiderivative. So what's the antiderivative? Well, that would be 1/3 x plus 2 over 3 squared x squared over 2 plus, I keep my coefficient, and then I raise my power and divide by my power, plus plus n plus 1, x to the n plus 1 divided by n plus 1. Yeah, plus from 0 to 1, like so. So now, I can see that things reduce. Goodbye, 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 goodbye. Yeah. So now that I have that, well, I'm going to write it out so it's nice and neat. Plus x squared over 3 squared plus, I'll just write like this actually. X cubed plus plus 1 over 3 to the n plus 1 x to the n plus 1 plus dot 0 to 1. So now when I put in 1 into all of this, all my x's, well, that's going to be easy. That's just going to be 1 over these. And if I put in 0, well, that's going to go to 0. So what is my answer then? It is 1/3 plus 1 over 3 squared plus 1 over 3 cubed plus plus 1 over 3 to the n plus 1 plus Now, before I say that that's my answer, what I'm going to do is I want to just double check that my nth term is correct. So if I say that n is equal to 1 here, n is equal to 2, n is equal to 3, yeah, then this will be n is equal to n plus 1. This will just match up with my term number, and that is fine. Okay, and so what was the answer? What was asking? Find the first 3 non-zero terms. So first, second, third, and then the general term. So that answers that question. And then part D, it says, part D, find the sum of the series determined in part C. So I need to use my answer from part C, which is this guy, and I need to find the sum. Most often, when they want you to find the sum, the actual sum, not an approximated sum, then they're looking for, most often you have an infinite geometric series, because then you have a formula that you can work with. So, and you can see that this is a geometric series because we're multiplying by 1/3 each time. So that means that it's going to be a divided by 1 minus r, which is a is the first term, which is this one right here. 1/3 divided by 1 minus 1/3. And this is going to be 1/3 divided by 2/3, which is 1/2. Yeah. And that's it. Hopefully that helps. Thank you.